Welcome to this video on data lifecycle. After watching this video, you will identify the various stages of the data lifecycle in enterprise data operations, describe how each stage contributes to transforming raw data into actionable insights, and explain the key practices involved in each stage of the data lifecycle. Managing data assets effectively has become essential for enterprises in today's world, where data drives almost every business decision. Enterprise data operations, or data ops, plays a crucial role in managing the end-to-end data lifecycle, ensuring that data is available, accurate, and secure at every step of its journey. Data goes through various stages, from when it is created to when it is archived or securely destroyed. Each stage helps transform raw data into valuable insights that businesses can use to make informed decisions. Understanding the stages of the data lifecycle from a data ops perspective helps organizations unlock the true potential of their data assets. The data lifecycle in enterprise data operations involves 6 key stages. These are data creation and ingestion, data storage and organization, data processing and transformation, data analysis and utilization, data governance and security, and data archival and destruction. Let's explore the purpose and key practices involved in each data lifecycle stage. The data lifecycle begins with data creation, which can originate from various sources, such as transactional systems, IoT devices, social media, customer interactions, and third-party datasets. Data ops efficiently handles diverse data formats, such as structured, semi-structured, and unstructured, by emphasizing automated and scalable ingestion pipelines. One key practice for data creation and ingestion involves leveraging integration tools such as extract, transform, load, or ETL and ELT to efficiently integrate data from different sources. Another key practice followed during this stage is to perform data quality checks by implementing validation rules to ensure the accuracy and completeness of incoming data. This stage also supports real-time data streaming, which is helpful for use cases such as monitoring, alerting, or rapid decision-making. After data is created and ingested, the next stage is data storage and organization. Data must be stored in repositories to ensure efficient access and processing. The storage strategy depends on the type of data and its purpose, from data lakes to relational databases. Data ops focuses on creating scalable and accessible storage solutions that align with business needs. Key data storage and organization practices include creating metadata repositories through data cataloging to enable easy dataset discovery and implementing a multi-tiered storage architecture to balance cost and performance, such as keeping frequently used data in faster storage and archiving older data. Another key practice is compliance readiness, which ensures data storage complies with regulations such as GDPR and HIPAA by integrating strong security controls and conducting regular access audits. With scalable data storage solutions in place, the next stage in the data lifecycle is data processing and transformation. The main purpose of this stage is to transform raw data into a usable format by focusing on cleansing, enriching, and normalizing data to meet business needs. Data ops relies on automation to ensure consistency and repeatability in data processing workflows. The key practice for this stage includes developing automated CI/CD pipelines to ensure the consistent processing and transformation of data. Another key practice during data processing and transformation is enriching data by integrating external datasets or leveraging machine learning algorithms to add value. Implementing robust error handling mechanisms is a good practice for identifying and fixing processing errors and maintaining data integrity. Building on the transformed data into a usable format, the next stage is data analysis and utilization, in which data is used for analysis, reporting, and decision-making. Business intelligence or BI tools, dashboards, and advanced analytics solutions are leveraged to derive actionable insights. Data ops emphasizes close collaboration among data engineers, analysts, and stakeholders to ensure the data effectively serves its intended purpose. Key practices include data democratization, which enables self-service analytics for business users while maintaining proper governance, Performance optimization, which ensures data models and queries are optimized for speed and scalability, and creating feedback loops to refine data collection and processing methods based on insights from analytics. The next critical stage is data governance and security, which ensures robust mechanisms and governance responsibilities are in place throughout the data lifecycle. From the data ops perspective, this stage's focus is to ensure data is used ethically, securely, and in compliance with regulations. Governance frameworks are essential to maintain data quality, traceability, and accountability. Proceeding to key practices, this stage involves managing access effectively by implementing role-based access control, or RBAC, and least privilege principles. Maintaining audit trails and logs to track data access and modifications for accountability, and using data masking techniques such as anonymization or encryption to protect sensitive data. The final stage of the data lifecycle focuses on data archival and secure data destruction. Organizations must manage retention as data becomes redundant or ages to optimize storage costs and ensure regulatory compliance. Here, data ops emphasizes designing and implementing archival policies aligning with business and legal requirements. One of the key practices for data archival and destruction involves defining clear retention policies based on data value and regulatory mandates. Other practices include utilizing cost-effective archival solutions such as cold storage for long-term retention and implementing secure deletion methods such as cryptographic erasure to delete obsolete data securely. In this video, you learned that the 6 key stages of the data lifecycle are data creation and ingestion, data storage and organization, data processing and transformation, data analysis and utilization, data governance and security, and data archival and destruction. The purpose of the data creation and ingestion stage is to create data from various sources, such as transactional systems, IoT devices, social media, customer interactions, and third-party data sets. The data storage and organization stage stores data in repositories to ensure efficient access and processing. Data processing and transformation involves transforming raw data into a usable format by focusing on cleansing, enriching, and normalizing data. The data analysis and utilization stage derives actionable insights by utilizing transformed data for analysis, reporting, and decision-making. The focus of the data governance and security stage is to ensure data is used ethically, securely, and in compliance with regulations. The data archival and destruction stage helps organizations manage retention by optimizing storage costs and ensuring regulatory compliance for secure deletion of obsolete data. Each stage has its own key practices to be followed for managing the end-to-end data lifecycle, ensuring its availability, accuracy, and security throughout its journey.